We're back and it's time for Module 4, Part 2. As we mentioned at the start of this module, it is super huge. In fact, I thought I was going to break it up into 2 sections. The first one went pretty long, so I like to have it more digestible. So I'm going to break up the next part even into 2 sections. So we'll have 3 parts to this module. Again, it's 30 to 35% of this. Very super important. So go back, rewatch these sections as you get ready. Ready? Let's go. So again, just a reminder where we're at in this thing. Natural language processing supports applications that can see, hear, speak with, and understand users using text analytics, translation, and language understanding services. Microsoft Azure makes it easy to build applications that support natural language. Natural language processing, or NLP solutions, use language models to interpret the semantic or written or spoken language. You can use the Language Understanding Service to build language models for your applications. Azure AI Language is a cloud-based service that provides natural language processing, or NLP, features for understanding and analyzing text. Use this service to help build intelligent applications using the Web-based Language Studio, REST APIs, and client libraries. Let's jump to the second part of this. An intent represents a task or action that users want to perform. It's a purpose or goal expressed in users' utterance. Define a set of intents that corresponds to actions that users want to take in your application. For example, a travel app would have several intents. So here are some other example intents in this diagram. Book a flight, greeting, hi, hello, good morning. Or check the weather. What's it like in Boston? Or none. Give me a cookie recipe. Did the Lakers win? So add intents to LUIS to identify groups of questions or commands that have the same intention. What is LUIS, you ask? Language Understanding, a machine-based language service to build natural language into apps, bots, and IoT devices. In conversation language understanding, entities are relevant pieces of information that are extracted from your utterances. An entity can be extracted by different methods. They can be learned through context, matched from a list, or detected from a pre-built recognized entity. Every entity in your project is composed of one or more of these methods, which are defined as your entity component. So to create an entity, you want to sign into the LUIS portal and select your subscription and authoring resource to see the apps assigned to that authoring resource. Open your app by selecting its name on the My Apps page. Next, select Build from the top navigation menu and select Entities from the left panel. Then select the entity type. Continue configuring the entity. Then select Create when you are done. So even better than this graphic, get in the portal, take a look at it, and see what it looks like and what the options are to configure. That's always a great way to get ready for these exams. After you've completed labeling your utterances, you can start training a model. Training is the process where the model learns from your labeled utterances. To train a model, start a training job. Only successfully completed jobs create a model. Training jobs expire after 7 days. After this time, you will no longer be able to retrieve the job detail. If your training job completed successfully and a model was created, it won't be affected by the job expiring. You can only have one training job running at a time, and you can't start other jobs in the same project. Model evaluation is triggered automatically after training is completed successfully. The evaluation process starts by using the trained model to run predictions on the utterances in the training set and compares the predicted results with the provided labels, which establish a baseline of truth. CLU supports 2 modes for training your model: standard and advanced training. Start training your model from within Language Studio. Select Train Model from the left side menu. Select Start a Training Job from the top menu. Then select Train a New Model and enter new model names in the text box. Otherwise, to replace an existing model with a model trained on the new data, select Overwrite an existing model and then select an existing model. Overwriting a trained model is irreversible, but it won't affect your deployed models until you deploy the new model. Next, you select your training mode. You can choose standard training for faster training, but it's only available for English. Keep that in mind. Or you can choose advanced training, which is supported for other languages, hint, hint, and multilingual projects, but it involves longer training time. So we have links in our links provided about training modes. You want to take a look at that. Select the data splitting method. You can choose automatically splitting the testing set from training data, where the system will split your utterances between the training and testing sets according to specified percentages. Or you can use a manual split of training and testing data. This option is only enabled if you have utterances to your testing set when you labeled your utterances. And then finally, you select the Train button. After training is completed, you can view your model details and see how well it performs against the test set. Go to the project page in Language Studio. Select Model Performance from the menu on the left side of the screen. In this page, you can only see the successfully trained models, F1 score of each model, and model expiration date. You can select the model name for more details about its performance. Note that models only include evaluation details if there was test data selected while training the model. In this tab, you can view the model's details such as the F1 score, precision, recall, date and time for the training job, total training time, and the number of training and testing utterances included in this training job. You can view details between intents or entities by selecting Model Type. After you've reviewed the model's performance to decide it's fit to be used in your environment, you need to assign it to a deployment to be able to query it. Assigning the model to a deployment makes it available for use through the Prediction API. It's recommended to create a deployment named Production to which you assign the best model you have built so far and use it in your system. You can create another deployment called Staging to which you can assign the model you're currently working on to be able to test it so it simulates the real-world production. You can have a maximum of 10 deployments in your project. After the deployment job is completed successfully, select the deployment you want to use from the top menu and select Get Prediction URL. After the deployment is added successfully, you can query the deployment for intent and entities predictions from your utterances based on the model you assign to the deployment. You can query the deployment programmatically, guess how, through APIs, the Prediction API in particular, or through the client libraries like the SDKs. If a solution needs to be always available, then you should design it to fail over into another region. This requires 2 Azure AI language resources in different regions and the ability to sync your CLU models across regions. Replicating a project means that you export your project metadata and assets and then import them into a new project. This only makes a copy of your project settings, intents, entities, and utterances. Think about those terms. Make sure you get those down tight for this section: intents, entities, and utterances. You still need to train and deploy the models to be available to use with runtime APIs. Make sure to read through the article on backing up the models. Here's a summary of the steps involved. First, you get the resource keys, export the project assets, then you import to a new project, then you train the model, and then deploy the model. This is a common example on Microsoft exams of process steps. Since part of this exam involves implementation, sometimes you may have to drag and drop these or select these from menu choices. So I don't know if this is an option you may get, but it's just an example of how sequencing of events in implementation matters on exams. We'll call that a quit for this one, make it nice, short, and sweet, and we will give you one more section coming up next.